Hi, good morning. Hello, everyone. I hope it is as sunny and lovely where you are as it is where I am. Welcome to this webinar. I'm just going to give it a few seconds to let everyone join, and then we're going to get going. But yes, good morning. Hello. Welcome. Okay. Before we get started, hi, my name is Georgie Ryan Casling, and I am the Head of Partnerships for Witekio, and I'm just going to run you through a little bit about what's going to happen before we get into the technical presentation with our engineers. So don't worry, it's not me. So first of all, this is a pre-recorded webinar from the Zephyr meetup that happened in France last week or the week before, but we will have our engineers available on live on this platform afterwards. So if you're watching and you have questions, please do put them in the chat, whether you're on LinkedIn, whether you're on YouTube or anywhere else. Please ask your questions. And at the end, we'll have two engineers, one Joël and one Matt, one from France, one from the UK, to come on and answer all of your questions. So don't be afraid. If you're new here and you don't know who we are, so we are Witekio. We are an embedded and IoT software company. We've been in the business for 22 years. We're part of the Avnet family. And we have offices across Europe, so in France, Germany, the UK, and in North America in Seattle. We have over 180 Witekians across the world. The majority of those are engineers, and we do 350 projects annually. We focus on a lot of different industries, so any kind of connected device or device that has a screen, public vending machines, home appliances, medical devices, heavy-duty machineries. You got it, we can help. We also work with all of the technology that you know and love, such as Zephyr or Yocto or Free RTOS, etc. And we are partners with some of the biggest names in tech and the silicon vendors like NXP, ST, Renesas, etc., etc. And finally, what we can help you with. Why are we the people that's talking about Zephyr? Why would you trust us or trust our engineers? Because we do everything from kind of hardware understanding to your firmware and BSPs, your middleware and applications, AI integration, up to the actual HMI and GUI, cloud and beyond. So that is it. So without further ado, I'm going to be quiet and I'm going to let the man of the hour, Joel, show his presentation. Thank you so much.
We'll speak about security and why Zephyr is really a good solution to help us making some secure product. This is a technical presentation. There will be some piece of code, some maybe difficult details. Don't hesitate maybe to ask questions after or to come to see me if we don't have time. But I promise about something. Zephyr can really help us to address these issues. Who I am? I'm Joël Guittet. I'm an embedded developer. I'm working at Witekio. I'm doing Linux development, kernel debugging, drivers, and also MCU. I'm using Zephyr, RTOS, Redux, and so on. So yeah, I'm used to deal with this kind of topics. This is our agenda for now. This is 30 minutes talk, so please be concentrate. It will be a bit difficult. First, a quick overview of what means security, what is Zephyr RTOS, even if we speak about that a lot tonight. Then we will speak different topics. We will start with firmware integrity, what it means, secure communications, user modes and memory protection that Zephyr offers. We'll go a step further using trusted environment and speak about also some security standard and so on to conclude the talk. First, why security really matter for embedded products? First, because our products are more and more connected. You know that. Whatever it is, something you have, an appliance in your home, for example, a baby phone, maybe a connected outlet that you have bought in China, of course. All those devices may be vulnerable or may include some threats that you don't know. Some of them have your personal data inside, and you don't want those personal data to be broadcasted somewhere on the internet and something. This will be, a real problem. In the industry, we may also think to the environment, and if a PLC, logic controller, or something else, is a backdoor for the entire factory, then it's really an issue. Even if it is a small device like a Zephyr device or running any OS or even a bare metal system, if it is a backdoor to access something else in your factory, then it's an issue. I just speak about the connected outlet you bought in China just before. That's really a true story. Some connected outlets you can buy in China are just there to spy you in your company and access your servers and send it back to somebody you don't know. So that's a problem. And the last topic there, and that forces you to take care of security, is law. And particularly Europe, that today force makers to ensure the products are safe, are secure. There is no punishment for the moment, but it's only for the moment. The goal at the end is to keep customers, your customers, confident with your product, so you keep using it, and to keep, of course, a good image of the company in which you are working. If the image is decreasing or something bad happened because of losing some personal data and so on, then it will be very hard for the company to be up again. What is difficult there when we speak of security is that initially or historically, we'll say, it's something that is addressed there, and some company is doing something like that, another like that, and another is doing something else. It's fragmented. And that's an issue. You don't know the vulnerabilities of such kind of product compared to another one, and so on. We need some standard solution to address this. One more thing about standard is that it permits also to save time and money, of course, for your company, and you can focus on developing your products. So that's something that looks good. But starting there, if you have never tried to do something secure, or if you don't know whatever it is, you may have plenty of questions, some few of them on this slide. What is firmware integrity? What is secure boot? What means protecting data in my system? This is an MCU. I know Linux, it's fine. We have Opti, just discussed before. We have a possibility to encrypt something, to decrypt. We have plenty of power, that's fine. But what about MCUs with some small memories and capabilities? We really don't know. What means secure communication as well? Which tools should I use to do that? Many tools that you may know from the Linux ecosystem are not back portable at all on an MCU just because of the size of the memories, of course. What is Zephyr? Zephyr, you all know maybe now, I hope so. It's an RTOS, so kernel, but it's also a complete ecosystem. It's hosted by the Linux Foundation. And there is around Zephyr, a very, very, very active community. That could be individuals, but also organizations. It's working on many architecture, ARM, for example, and so on. It's fine. It's configurable a lot. We speak earlier of kconfig. I will give a few examples later. And it's modular. So with this kind of configuration, you can build something very more modular, as done by Gardena, for example. That's very fine. It also uses device tree concept that is coming from the Linux world as well. That's really fine to declare the hardware part. There are many drivers, subsystems. If you want to do the lower one, if you want to do lightweight M2M, if you want to do HTTP, if you want to do Bluetooth, if you want to do maybe Zigbee, I don't know, to be honest. But by the way, many drivers and subsystem included in the ecosystem. And it's running over 700 boards today that are supported inside the main repository. It's also very easy to add your own. So looks good. It's permissive in terms of license, Apache 2.0. So could be used in commercial products. But the opposite, maybe we know, just raise your hand, Zephyr RTOS, Redix, a bit. Okay, not bad. Yeah, they have not so much rich ecosystem. If you are using Redix, for example, you know the NetX Duo platform, USBX, FileX, that's all. Not so much possibilities, not so much support and active community. By the way, what is important is also that Zephyr don't miss the security aspect, and this is the purpose of this presentation. I promise in the agenda, I'm starting with firmware integrity. The threat here is tampering the firmware. What I mean, if somebody is able to execute a code that you haven't validated, tested on your hardware, that's really an issue. There is a risk to expose data, security assets, or even some algorithms or expertise that you have in your company. If someone is able to pick your firmware, replace it, and do something else with the device. Just think again to the baby phone, for example, that you have to look at your baby. That's really cool. But if someone is able to tamper with the firmware and do something else with the camera that you don't know because you don't realize he is doing that, then there is a leak and it could be a problem. The mitigation to this is secure boot. That means the firmware to be executed on the platform when the system is starting must be verified, either using the internal bootloader of the MCU, if it exists, or using your own. Zephyr here proposes a standard solution which is based on MCU boot. And what is really magic is that you just have to configure, build the bootloader, very easy. I will see an example just after. Select and update maybe an update framework if you're doing some over-the-air updates. Personally, I'm using Mender. I love Mender. I'm the author of MCU client for Mender, but there are others, including in the Zephyr repository. Yeah, and that's all. Let's check for details. I promised some codes, but not for the moment. Just imagine you want to do your own bootloader. Quite nice. Let's create a project, main.c file, main, void, what else? You can do it by your own, no problem with that. From scratch, that's working. You can also use MCU boot, as Zephyr do, no problem with that. So if you was using MCU boot, I suppose you do with MCU boot, you will integrate the MCU boot source code, that's on GitHub, that's fine. Then you will link with the boot util part of the MCU boot. This is like a library, I will say, in MCU boot that will handle verification of your firmware. And then you will have to implement jumping to the code. Implement also the flash map wrapper that is reading and writing the memory, configure some MCU boot options, tuning all the options, testing, and so on. Wow. A bit difficult and maybe plenty of bugs. Or you can just use the bootloader that is proposed by Zephyr. It's very simplified. The just thing you have to do is declare the mapping of the memory in your MCU. This is an example on the left, a bootloader part, application and update slot, so where your application will be. The scratch part is optional, that depends on MCU boot options, and that's fine. Here we are building the Hello World application that's come from Zephyr. No modification at all. You get in your build directory the bootloader and the application, that's fine. It's signed, verified on the boot. Just use it. What about communications? We said in the introduction, it's more and more connected. So we need to communicate. We need to communicate to some server, to other devices, and so on. Here, the purpose is to protect against compromising or tampering the data in general. Maybe some hacker that wants to check for your data and access some personal data and so on. The mitigation here is TLS. We are speaking of IP-based communication generally. Here I will not address LoRaWAN or some other protocols that are maybe a bit specific and have their own mechanisms to protect data. Here I'm speaking about HTTP, MQTT, and so on. We need here to encrypt data, and we need also authentication of the server, and even better, mutual authentication of the device to the server. So you can reject a device that has been compromised in the field. Zephyr here proposed to use the well-known embed TLS stack as part of the standard solution in its networking stack, I will say. And what you have to do there is only to configure sockets. You will see a code example just after. That's very, very easy, I promise. Yeah, and let's check for the details now. Oh, of course. You are not convinced for the moment, so you want to do it the hard way, or you are using NetX Duo, for example, with ThreadX. So you create a socket, you create a TLS session, you have to configure it, dealing with Zephyr. We know with Zephyr. You know what is ciphers, protocols, and so on. That's really a complicated job. You deal with buffer size overflows, plenty of bugs like that. And when the session is closed, you have to clean up everything, making sure that you are not losing some memory in your system, and you have very few memory, remember. A bit complicated. Zephyr here propose a simple solution to do that. Let's suppose we are doing some HTTP connection, for example. What I have to do, and this is the purpose on top right of the slide, is declare and register in Zephyr the security assets I have on my device. This could be some certificate, private keys, and so on. If you're using lightweight M2M, for example, we have seen with Gardena, this is a key and an ID. And then, when using a socket, just declare the socket option to use these security assets. This is all there. I promise. Nothing else. And if this fits on this slide, this fits in your code. Be sure of that. Maybe just some few notes or advice. Here we have device and server authentication, so mutual authentication, that's really good to have. In terms of protocols, please avoid TLS 1.0, TLS 1.1, DTLS 1.0. By the way, it has been removed, I think, in Zephyr 4.0 release a few months ago now, so it should be fine. But for release 3.7, for example, the latest LTS, yes, really, please use TLS 1.2 or prefer 1.3 if possible. But that's all. One more topic. User modes, memory protection, and so on. When we speak of vulnerabilities, and we can see about that in general, the most common vulnerabilities are protection of memory. You know about buffer overflows that permit an attacker to do something else on your device, and so on. This is about, I think, if I remember properly, 70% of the vulnerabilities that exist and that are discovered. Vulnerabilities related to memory management and protection. There, the risk is that we can expose some data, some personal data, security assets, and so on and so on. That's all the same story. We may want to isolate at least the thread between each other and the kernel itself. So we can execute some untrusted code, For example, if you know about LLX extension in Zephyr, that's really cool, but you may want, if you put a module from somebody else in your device, you may want to run it without too much privilege. Zephyr here proposed to have user mode and to partition the execution, I would say, with some memory protection mechanisms. Maybe just before looking in detail at that, you may also want to check at the Rust support. Just been released, I think 1 or 2 weeks ago, in version 4.1 of Zephyr. That's very, very new. Not a lot of feature inside, but Rust is known to be really good in terms of memory management, so could be a good option as well. I'm not a Rust developer, I don't know Rust, so I can't answer a question about that. By the way, making a thread in Zephyr having user privilege, so less privilege than the kernel, is very simple. That's also on this slide. Very similar to you creating a classic thread, just adding the K-user option on the bottom left there when creating the thread. However, the problem with that, it will create some overhead when you will need to access some drivers or the kernel itself, because there are some syscalls and so on that create an overhead. So use it with care. That's not the perfect solution with that. Zephyr also has memory protection mechanism that you can use together with that. You can define some region with some specific access, read-only, read-write access, and so on. But for that, that depends on the MPU. So it's really important also to select the hardware properly if you're doing that. So having the MPU peripheral inside. A small one that I think is really cool is about stack protection, either using the MPU if it is available, or checked by software for some very small device. Is about the stack protection. If you run out of the stack, you have a nice message that is on this slide that is displayed in the console. So you know either that you have something to do in terms of memory management, or maybe you have to increase the stack, possible. But it also means that there is no memory corruption somewhere else, particularly in the kernel, of course. Cool feature. Okay. 20 minutes. If you have done that, you have done really the bare minimal in terms of security. That's just really the first step. You can't do less than that. For the reason I have introduced at the beginning of the show. Just think about the personal data and security and the confidentiality of the data from your customers. They don't want you to lose this kind of data. We can go maybe a step further. I like this, so it is added there. It's about trusted environment. You speak just before of Opti a bit. This is like the Opti for MCU. What is it? I'm teasing. There again, the thread is comparing the system, accessing some security assets, particularly. So by security assets, when I say security assets, it's private keys, certificates that permit to connect to a remote server and so on. And Zephyr there also propose to integrate TFM. TFM stands for Trusted Firmware for Cortex-M. We will see just after what it is. And really, it's easy to configure, even if we have to configure it a bit. TFM is a framework. I like this picture that is coming from the TFM website. And the purpose of this is to isolate your application there, running on top of Zephyr RTOS, that's the gray part. You see the RTOS box, of the rest of the system there where the security assets, protected data are. Okay? The blue part and also the green part. Between the two worlds, there are some APIs that are called PSA APIs that permit to access the feature of the secure world from the unsecure world. This is enforced, but not mandatory, but it's running very well on Cortex M33 and so on, that has trust zone, because the isolation is enforced at the hardware level. And using that, it's totally impossible for an application there, even if it has been compromised, to access directly some security assets protected in the secure environment. Even the memory is not accessible. Okay? What's in TFM? First, on the bottom right, secure boot. It's based on MCU boot. That's the bootloader. We already seen that. And we have some secure services. Not mentioning everything, but some cryptographic functionalities and some internal storage functionalities that permit to store your security assets, private keys, and so on. What it's not in TFM is your application, of course, and because it's not on the schema, network communication and so on that are there on your left. We don't have network communication there on the right. Drivers and so on, networking stack are on the left. And for that, Zephyr proposed a really simple way to integrate TFM. If you have done that by yourself, that's much complicated, to be honest. That's taking days or even weeks. Here, if I want to integrate such feature in my system, I just configure the memory map as shown on the left. That's very similar to the MCU boot one we have seen. I just need to describe where is the secure zone, where is the unsecure code, and I tap this command. This is an STM32 board running Cortex M33. That's fine. I get 3 binaries, MCU boot, the secure application, TFM itself, and my Zephyr application on the left. Run it, that's fine. And even if you don't have such board, you can use QEMU inside Zephyr to use it. There is a board for that. Just one thing to mention there, the board needs to be compatible. There is only some few boards compatible with that. And it's terminating with NS, non-secure acronym at the end of the name of the board. I will jump that. Yeah, last but not least, compliance with security standard. We are losing a bit of code there, but it's important also to care of that. And if you care of vulnerabilities in general, you have an email address to send them if you think you have discovered some vulnerability. A list is maintained and fixes are done very quickly, I guess, and backported on the latest LTS. That vulnerability comes also with SBOM, software bill of material, that permits to describe which packages you have in your device and help to manage vulnerabilities to fix them in your product. There is a WEST command as well to produce the SBOM report at the SPDX format. This is a standard format to describe software packages in your devices. Security standard also that Zephyr take care. It's also PSA certified, for example. The kernel itself, I mean, it's a way to help makers being certified. But Zephyr take care of this kind of topic as well. Yeah. In conclusion, Zephyr is really great, I think, from a developer point of view. And what is really the best is that it also addresses security issues we have in our devices and MCUs. And at Meetup, we are really convinced this is a really good solution to develop secure devices, including for industrial application, I mean medical devices and so on. Just maybe one example we work on, just to say it's not just words, but it's also real life. We take your work on this device. That's a small credit card format, the same size, running Zephyr RTOS, screen, battery, fingerprint, and it's used to authenticate with, for example, your company, SSO, and so on. Thanks.
Thank you so much. So that is the presentation. I'm just going to ask now, I'm looking into the chat before I introduce our engineers. Here we go. So Joel and Matt, this is Joel. Obviously, he's the one who did the presentation. Thank you so much. That was great. And Matt is here as well. Hi, guys. So are there any questions from what I can see from the comments? I don't see any yet, but I can see you guys are still watching. Are there any questions that you'd like our experts to answer? While we wait for them, just in case anyone has any questions, I know no one likes to be the first, right? No one wants to be the first one to ask a question. So how about I'll ask one? Why would people choose, and obviously Joel and Matt, you went over it in some of the presentation, but why do you prefer Zephyr, or why would we suggest as Wittekio Zephyr over, say, ThreadX or FreeRTOS? Is there a specific set reason, or is it a wide subject? Sure.
Maybe I can start. Yeah.
Yeah, you go, John.
Yeah, that's plenty of reasons. In fact, maybe some few of them, because this is a modern solution that developers really like. We are speaking of device-free, SK-config, and so on. So that's really modular and very easy to use. Instead of spending a lot of time to set up everything and get it built again and again. So that's very good for this point. And this benefit is also a benefit for our customers, because it's very, very easy to do maybe some proof of concept very quickly, just adding the few elements that we want in the application. We can demonstrate something very easily and very quickly with Zephyr.
Nice. Matt, anything to add?
Yeah. For me, it's the level of kind of hardware abstraction you get with Zephyr is really nice. So I work with software running on a whole bunch of different hardware platforms, different silicon vendors, all of that, and being able to write all of that using a common API is really nice, and not having to learn the intricacies of exactly what that hardware supports and how this peripheral works on some other hardware is nice.
Okay, nice.
And the other cool thing you get with that level of hardware abstraction is that I've done projects before where you effectively write pretty much the entire software running on an off-the-shelf dev board, while the real hardware is still kind of being designed and manufactured to some extent. And then you get an experience where the real hardware turns up, you write a few device tree files, and oftentimes it'll work first time on the real hardware, despite the fact that you haven't even used it yet, which is a really cool feature.
Okay, nice. So I'm hearing that it gets device makers quicker to market because it's easier to use. Also, it's easier for developers to be able to work with, and it connects a lot easier. So that's why. That makes sense. Okay. If we don't have any other questions, I'm going to let our guys go. But everyone watching, thank you so much. If you do have questions and you're just afraid to answer live, I get it. It can be daunting. You don't want to put your question. Then you can contact us at hello@wittekio.com, and I promise either Joel or Matt will answer your questions. I will forward them to them. You can also check out wittekio.com to find out more about what we do, especially around Zephyr. So thank you so much to Joel and Matt for everything they've done. And thank you to everyone for watching. Have a lovely day, and we will see you later. Bye, guys.
Bye.
Bye, everyone.